Okay, quiz day. Just a couple problems to solve, a couple equations to solve. Okay, the second equation, people did pretty well with the second equation, at least as far as getting the solution, but we want to be sure we understand how to write this out. Okay, so the logic of this is very simple. If something times something else, if the product of two numbers is zero, that means one of them has to be zero. So we can write this as x minus 3 equals 0, or x plus 4 equals 0. I want to see that written out with the or. Okay? Because we need to understand the logic of this, and when you write it out with the words, because that reinforces the logic. Okay. So, and then very easy to solve this. Obviously, then x equals 3, here x equals -4. So your solution step, and you should write it this way on your paper also. Now, when you're in open math, you just give the two solutions with a comma. And most people did that pretty well, okay? If you write it on paper, it's a set, so you put set brackets around it. And you write it like this, and you identify that as the solution set. You want to write out all these words because they're important for understanding what comes later. Okay. So again, everybody should be in shape to understand this because everybody saw what the solutions are and applied I hope, applied the zero product criterion. The common sense idea that if two things multiply out to zero, one of them's got to be zero. It could be either or. All that is important. Okay. Now, solving this. Okay. Now, people did fairly well with solving these problems in open math. But people had a lot of trouble with this problem when they came to class. Okay. So this tells me that maybe you're relying too much on something you have in front of you when you do the problems. Okay. If you have the way to solve it sitting there in front of you, you're going to imitate it without necessarily pulling it out of your memory and understanding it. And of course, that's one of the reasons I gave everybody the big set of supplementary problems. You want to get to where you can do those. Okay. So again, people did fairly well problems of this nature when they were doing it in open math, but pretty much nobody was able to do this in class. Okay. So we have x cubed plus 5x squared plus 6x equals 0. Well, it's pretty obvious that using the distributive law backwards, this gives you x squared plus 5x plus 6 multiplied by x. If we multiply x by x squared, we get x cubed. Multiply x by 5x, we get 5x squared. If we multiply x by 6, we get 6x. Every one of these terms has at least an x, at least the first power of x, so we can always see to do this. And we have to look at it, okay? Because once you've done this, you simply factor this expression. Now, of course, that can be a challenge also because we've recently experimented with factoring these things. We can write out all the possibilities and see which one works. And you want to do that. So once this is factored, once you have the x factored out, it's very easy to factor this particular quadratic. Now, some quadratics you can't factor. Well, you would have to use the quadratic formula, which we haven't talked about yet. Okay. But at this point, this thing is probably going to end up being factored. Now, what can you do? Same thing we do here. This splits. Now, there are three things multiplied together. If any one of those three is 0, you're going to get 0. So this means x equals 0, or x plus 3 equals 0, or x plus 2 equals 0. Now we can solve that. Well, x equals 0 is just x equals 0. Or x equals -3. Or x equals -2. So the solution set is 0, -3, -2. You're probably right. Maybe write them different order, but ascending order, but I just wrote them in the order they came out. Okay. Probably be better to write it -3, -2, 0. Or even 0, -2, -3, so there's some kind of order. Still, that's it. Now let's just do slightly more college example. How are we going to solve this? I'm going to let you see if you can write out the logic as I did. And just see how you do with this. Give you a couple of minutes. Okay, so everybody did quite well. Following the pattern we have here, we can split this into two equations. 3x minus 5 equals 0, or 2x plus 7 equals 0. Didn't really check to see that everybody had that or in there, but it should be there. Okay, so can we solve the equation 3x minus 5 equals 0? Add the same thing to both sides, subtract, multiply, divide. Use the techniques of solving linear equations. Okay, well, what do? We solve this equation. We solve this equation. And let's put the or in there. Okay, so we got 3x minus 5 plus 5 equals 0 plus 5. And then that gives us just 3x equals 5. So 3x over 3 equals 5 over 3. And that tells us that x equals 5 over 3. Or, it might seem tedious to write all these orders. You put quote marks there for some things, as long as you indicate that you understand the ors here. But you definitely want the or written out on your last step. So we have 2x plus 7 minus 7 equals 0 minus 7, which gives us 2x equals -7. Gives us 2x over 2 equals -7 over 2, which gives us x equals -7 over 2. Okay. You know, that's very straightforward if we understand just how to solve the simplest linear equations. Okay, and that should be pretty automatic. You need to practice that if that's not automatic. But some people need a little bit of prompt or a little bit of confidence to do it, but then they do it perfectly well. Okay, so make sure that you know exactly what to do when you get a linear equation. So now our solution set is 5/3 -7/2. Okay, well, nobody was able to add this because fractions aren't taught well in the secondary schools. Nobody knows how to do fractions when they get to college. And even though we covered it early in the semester, people did the dozen or so problems, and I'm right, but nobody seems to remember. And this is typical. Okay, this is very important when you add fractions. Now, the most common thing I see here is you add the 3 and the 2, and you add the 4 and 7, you get 5 sevens. This is clearly wrong. 3/4 is greater than a half. 2/3 is greater than a half. Yeah, if you got a pizza, cut it into 4 pieces, take 3 of them, that's more than half the pizza. Cut it into 3 pieces and take 2 of them, that's more than half. You add those together. Well, half and a half is 1. So there's got to be more than 1. If 5/7 is less than 1. That's a contradiction. Okay, so we'll take a lesson from this. You can't add 2 things, each being greater than half, and get something less than 1. It's like, I take more than half of this pizza, I take more than half of this pizza, but I've got less than a whole pizza. They're the same size, there's something clearly wrong. Get 2 pizzas for some size. Okay, so what do we do? Common denominator is 3 times 4, which is 12. Smallest number that both 4 and 3 go into. Okay. So take the 3/4, multiply that by 3/3. I get 9/12. You get 9/12. Now, if you divide the 9 and the 12 by 3, you get 3/4. So 9/12 is the same as 3/4. But it's in a form, we're going to be able to add this if you express the 2/3 with the same denominator. Now we got 9/12 plus 8/12. So now it's like we cut the pizza into 12 pieces. You take 9 of them, I take 8 of them. Well, we can't do that because they're 12 pieces. Maybe we've got 2 pizzas and we cut each of them into 12 pieces. Then I can take 9 and you can take 8 and there's still something left for somebody else. Because 9/12 and 8/12, that'd be 9 slices and 8 slices is 17 slices. Each one of them is a 12th of a pizza. So that's less than 2 pizzas. 2 pizzas would be 24 12s. So that makes a certain amount of sense. Now, whether you think it through like that or follow the algorithms or whatever, we have to understand that you multiply, when you multiply fractions, you multiply numerators and multiply denominators. When you add fractions, you have to have a common denominator. And this is how you do it. And you need to review this, okay? It's something that just needs to be second nature. It's something that's a little bit confusing, but with practice, it becomes very easy. So my only advice is do a lot of practice. The problem sets that I set out have, if you go online, you have hundreds of fractions to add. And, with solutions. So sure, you practice. Practice there, find something else on the internet, but learn to add and multiply fractions. Because we're going to do it now with symbols. We've been talking about rational expressions. Now, I get a test needs to get taken. So I understand people haven't done the assignments that were due today. And most people are pretty well up on most of the assignments that were due earlier. So I have to assume people spend time practicing for the exam. And again, that simply takes hours of practice and feedback. And remember, you can show me your work on some of those problems. You can scan it and send it to me. You can bring it to me. We can take a look at it and see what it is you might be missing. You can even show it to me in class. Okay. Let's say now we have x plus 3 over x minus 5, and we want to multiply that by x minus 2 over x plus 4. What do we get? Now let's just review just a bit more, make sure we understand. What would, of course, that was on, let's flip over to the back side here. What is three-fourths multiplied by 2/3? Okay, most people are a little unsure of the rules. And as I said, you just got to practice. You got to do hundreds of these. Okay, 3/4 times 2/3 is 3 times 2 over 4 times 3. Now, this is what people want to do when they add, but it doesn't work for addition. We just showed that it can't work for addition unless you have the same denominator, and you wouldn't add the denominators, okay? Think of the logic of why we add the way we did. Think in terms of slicing up a pizza. Okay, so we get this, and that equals 6 over 12. And of course, 6 over 12 is 1/2. Okay, well, that's the rule. We multiply numerators and we multiply denominators. That's easy. Adding is a little harder because you have to have a common denominator. Dividing is just like multiplying, except you got to invert the thing you're dividing by. Okay, so what do we do if we have x plus 3 over x minus 5 multiplied by x minus 2 over x plus 4? See if we can write out the result using the rule for multiplication. Nothing mysterious about it. Okay, now we got something pretty much right. Most people, some people wrote like this: x plus 3 dot x minus 2 over x minus 5 dot x plus 4. Now that's not quite right. It's the right idea. You multiply the numerators and you multiply the denominators, but the x plus 3 is not multiplied by x minus 2 the way this is written. The only thing's multiplied is the 3 times the x because of the order of operations. In order to multiply this numerator by this numerator, we have to have parentheses around these, in which case we don't really need the dot, although the dot's optional. So we have to write it carefully. But then we just proceed to use the distributive law. And I'm not going to ask everybody to do that. We get x squared plus x minus 6 over x squared minus x minus 20. And there's nothing we can do to reduce this because neither of the quantities in the denominator divides either of the quantities in the numerator. The only way this could be simplified is if one of these up here matched one of these down here. Okay. So the multiplication is pretty easy. Let's try x minus 5 over x plus 7 divided by x plus 3 over x plus 5. What's that going to equal? Okay, well, not everybody's done, but everybody did do the correct first step. You do the reciprocal of the thing you're dividing by. This is going to be x minus 5 over x plus 7 multiplied by x plus 5 over x plus 3. We do the reciprocal of the divisor. And that gives us x minus 5 times x plus 5 divided by x plus 7 times x plus 3. And that equals, we use a distributive law or special products. In this case, we have a special product like x minus 8 times x plus 8 is x squared plus 6 squared. And down here, we're going to have x squared plus 10x plus 21. Okay. So that's really easy. All I got to do is remember for division, you got to take the reciprocal of the divisor. Then you multiply numerators and multiply denominators. And I think people are pretty good with the distributive law. If not, practice more. Okay. Ouch. That wasn't a good time. I don't know why I said ouch. Just worry about knocking something off. Okay, just loose over there. Okay. So let's try x plus 3 over x minus 5 added to x minus 2 over x plus 4. What's that going to equal? Okay, now I'm gonna probably need to give a little hint. The denominator is x minus 5 times x plus 4. Now, just for reference, I'm going to write down two-thirds plus 3 or 3/4 plus 2/3. The common denominator is 4 times 3 is 12. So you have to write this as 3/4 multiplied by 3 over 3 plus 2/3 multiplied by 4 over 4. Once you've done that, you're going to end up with a common denominator of 12, and you can add the resulting numerators. Okay? Now, see if you can kind of take that as a guide and see what you do with this. I'm only going to give you a couple minutes because a lot of people probably aren't going to see it immediately. But it's possible that everybody will. So I'll give you a chance to do it. Okay, so here's your common denominator. Now, people were able to make the right conjunction. Okay, so that was very good. We can write now x plus 3 over x minus 5, and we multiply that by x plus 4 over x plus 4, so that the denominator will come out x minus 5 times x plus 4. Now I've got x minus 2 over x plus 4. We multiply that by x minus 5 over x minus 5. Now, when we multiply that out, that's where people kind of went wrong. Okay? When you multiply x plus 3 by x plus 4, you don't get like x plus 7 or something like that, because you're not adding these things, you're multiplying them. So you have to write out the step. X plus 3 multiplied by x plus 4. Remember over here, I emphasized you have to multiply this by this, right? Okay, so when you multiply two rational expressions, you have to multiply the numerator by the numerator. The numerator is x plus 3, and you have to put that in parentheses. And then times x plus 4, which has to be in parentheses. Same thing here, you got to multiply the whole denominator of this fraction by the whole denominator of this fraction. And then you do the same thing with the other fraction. And now what do you get? Well, you know, when I multiply these fractions, I wrote x squared plus x minus 6 over x squared minus x minus 20. Because I'm assuming everybody knows how to use a distributive model. Now, that's what we've been doing recently. Okay? So I'm not going to go through the details of that. You probably need to review that, but that's what we use in reverse to do all the factoring that we've done. So you got to kind of pull that together. I'm not going to leave it to you to pull it together. If we don't have it, by next time we'll go back and talk about it, but probably best if we don't use class time to do it. You just have to review it. And you're not going to be getting the right answers unless you do. But of course, Open Math is going to show you those steps. And we've been over it quite a bit. Okay. So when you multiply x plus 3 times x plus 4, you get x squared plus 7x plus 4. When you multiply this, you get x squared minus x minus 3. And then that's, well, actually, I don't want to multiply the denominator at this point. And I'll explain why in another step or so. Okay, so I'm going to leave the denominator factor for reasons you'll see in a minute. Okay, over here, we're going to get x squared minus 7x plus 10 over x minus 5 times x plus 4. Now, I switched the order of these two factors, but that doesn't make any difference. I just switched the order to make it real clear to the eye that these denominators are the same. Well, that equals x squared plus 7x plus 12 plus x squared minus 7x plus 10 all over x minus 5 times x plus 4. And now there's some simplification that can go on here. X squared and x squared is 2x squared. 7x and negative 7x is 0, so you don't have any x. 12 and 10 is 22. The denominator. And I'm going to erase this example, which is just there to give you a little guidance. And everybody seemed to have done the right thing with that. Okay. Now, you want to factor the numerator to make sure it doesn't have any factors that match these factors, because if they do, they're going to divide out. And you get 2 times x squared plus 11 over x plus 5 times x plus 4, and it's x minus 5, not x plus 5. Okay, well, x squared plus 11 doesn't factor. And one way of seeing that is x squared plus 11 can't equal 0. Because x squared is always positive and 11 is positive. You can't possibly get 0 out of this. Since you can't get 0, you can't write it. Well, I'm not going to go into the details right now. There's good reason you can't factor this. So if you wish, or if Open Math insists, you multiply the denominator out and get x squared minus x minus 20. and you're confident that this doesn't simplify. That's the process for addition. Okay, well, in this case, again, we find the common denominator. And some people, I see when you're making your notes, don't make it explicit that you're finding a common denominator. Just dive in and do it. And if you review your notes, you might forget that there's a common denominator involved. If you identify it clearly, it's going to make an impression and you're going to remember it and learn it faster. So we write this as x plus 1 times x minus 2. Then this first equation has to have that denominator. First, the x equation, first fraction has to have that denominator. So we're going to have to multiply by x minus 2 over x minus 2. And that'll give us this denominator. Then it's going to be plus x plus 2 times x minus 6 over x minus 2 multiplied by 1 over x plus 5. So x plus 1 over x plus 1. Okay, well, the numerator then becomes x minus 3 times x plus 4 times x minus 2 over x plus 1 times x minus 2 added to finally x plus 2 times x minus 6 times x plus 1 over x minus 2 times x plus 1. Then we have to multiply out our numerator. Multiply out our numerator, we're going to do, I'm just going to do it like this. We do x minus 3 and use the distributive law to multiply x plus 4 by x minus 2. And here we're going to have x plus 2 times x squared minus 5x minus 6. And all that is going to be over a common denominator. Now we have to use the distributive law to multiply this out. And I'm probably going to mess it up, so, work it out yourself, see if you agree with what I get. We're going to have x squared, we're going to have a 2x squared here, minus 3x squared here. This is a minus x squared. And you're not going to do it like this. You're going to write x times this minus 3 times this, and you're going to work it out the way we've always done. I don't have time to do that, and I don't want to confuse the issue by going through all those details. Make sure you know how to multiply this by this and multiply this by this. Okay, anyhow, then we're going to get minus 8x and minus 6x, so minus 14x plus 24. And if I haven't messed up, let's say we're going to have an x cubed from this. We're going to have a minus 5x squared and a 2x squared, which is minus 3x squared. We're going to have a minus 6x and a minus 10x, that's minus 16x, minus 12. All that over x plus 1 times x minus 2. I have to move to the left here. The numerator simplifies. We get 2x cubed. We have a minus x squared and a minus 3x squared gives us minus 4x squared. Negative 14x and a negative 16x is negative 30x. And 24 and negative 12 is plus 12. All that is divided by x plus 1 times x minus 2. Now, there are things we can do to try to factor this cubic, but you don't know what those things are at this point. So right now, we're just going to accept that as a final result, except I will mention if x equals negative 1 the denominator is going to be 0, right? If x is -1, you're going to get a 0. If x is -1, and you plug that in up here, you get -2 minus 4 -6 plus 30, 12. It's not going to be 0 up here. So -1 makes this 0, doesn't make this 0. 2 makes this 0. But 2 isn't going to make this 0. Okay, so that kind of confirms this is factor. Now, whether you understand that or not, you might see that in open math. I don't think so. So just stick with what open math tells you and see if you can get this assignment, because this is a big deal. If you can do this stuff, you're pretty good with your algebra. Okay. Very few pre-calculus students can, when starting, can do this. Okay. So then your goal is to get yourself in shape where you can reasonably start the pre-calculus course without having to trip over how you add fractions or how you solve linear equations and so forth. And without having to trip over how you do some of the harder algebra. You might not remember every bit of it, but if you get it down well here, it'll come back to you when you need it. And maybe you'll remember it.